Hello everyone, welcome to my presentation on unleashing the power of serverless for building scalable and cost-effective solution using AWS Lambda and GQGen. In this presentation, we are going to cover two most powerful technologies. One is serverless computing and another is one of the Go popular library GQLGen for generating GraphQL APIs. We'll start by exploring what is serverless computing, then we'll go in more deep dive about how we can implement using AWS Lambda, and then we are going to cover what is GraphQL APIs and how we can implement using GQLGen. Before going further, I just want to give a small introduction about myself. My name is Durgaprasad Budhwani. I'm working as a chief technologist at Tech9. Throughout my career, I always fortunate enough to work with latest technologies, with latest trends, and with various clients with multiple domains. And I always fortunate enough to provide them a cutting edge solutions which fulfill their needs. And this is what we do in Tech9. We always work on the latest technologies. Let's talk about serverless computing. In case of serverless computing, which is also known as function as a service, the cloud provider such as AWS, Azure, Google, or Vercel will manage the infrastructure and automatically allocate resources for running and executing the code in the response of any request or an event. In case of traditional computing, the developer has to manage the servers. It could be a developers or a DevOps team has to manage the servers. With serverless computing, the developer only need to write the code for the specific function they want to run, and the cloud provider will handle the infrastructure, scalability, and availability of those functions. This allows the developer to focus on writing the code and building the application without worrying about the underlying infrastructure. There are a lot of advantages of serverless architecture or serverless computing. One of the main primary advantage of serverless computing is a cost reduction. Since users only pay for the actual amount of compute time consumed by their functions, they can save money by avoiding the cost of managing and maintaining servers. Serverless computing can automatically scale to handle changes in demand. As the number of requests or event increases, the cloud provider can allocate more resources to handle those workload, ensuring that the application remains responsive. Serverless computing allows the developer to focus on writing code and building application rather than managing infrastructure. This simplifies the development process as well as the developer can only avoid the complexity of managing servers, load balancers, or other infrastructure component. Serverless computing allows developer to focus on writing code and building application rather than managing infrastructure, which include it actually simplified the development process. The developer has not to worry about managing servers, load balancers, other infrastructure component. With the serverless computing, developer can quickly and easily develop code changes without worrying about the underlying infrastructure. This can speed up the development process and improve time to market for new features and application. And serverless computing can improve the application reliability by automatically handling tasks such as server maintenance, load balancing, and scaling. This can help to reduce the risk of application downtime and ensure that the application remain available to the users. AWS Lambda is nothing but it's a serverless compute service provided by Amazon Web Services that allows developer to run the code in the response of event or request. With AWS Lambda, the developer can write code in variety of programming language which include Java, Python, Node.js, and then they can upload their code to run as a function in AWS environment. This service will automatically handle the compute resource, scaling, availability of functions so that the developer can focus on writing code and building application rather than managing servers. AWS Lambda support variety of programming languages. There are a couple of languages which are provided as a native, which include Java, .NET. If a programming language is not supporting AWS Lambda, but you can also create a Docker image, or you can also create your custom runtime, and then you can also run your code on AWS Lambda, which is basically is happen when you are choosing a PHP language. You can create your Docker image, or you can use a custom runtime in case of Rust language. AWS Lambda is often used for the event-driven application where code is triggered in the response of events such as changes in Amazon S3 or any new message which is pushed into AWS SQS, Amazon Q service, or in case of any message which has been pushed to Amazon Simple Notification. It can also be used to create API and run batch jobs and perform data processing tasks. So we are going to see how we are going to write a simple Go application for AWS Lambda. But before going to more on how we are going to write this for the AWS Lambda, first we'll take a simple example of Go application which is listening to any HTTP request. For that, we can see a simple example where a main is kind of starting point. This program is using Gin framework. Gin is nothing but one of the popular web framework. Here it is creating a router and the router is then listening to an HTTP request, a GET request. When someone is going to put for this specific request, it is going to return a hello world. And then at the end, this web framework will start listening to HTTP requests. on the port number 8080. That means when someone is going to hit the localhost HTTP localhost 8080 request, this will going to print the hello world. A very basic example in Golang Go application. Now, when you want to write a similar application for the AWS Lambda, in that case, now when you want to port the similar application for this AWS Lambda, then we need to do a couple of more changes. The same thing is we are going to use for the GIN framework for the routing. We need to import multiple libraries like AWS Lambda Go events, AWS Lambda Go lambdas, and then we are going to use this Lambda Go API proxy. So this proxy support for multiple framework. It support for Fiber, it support for Gorilla. It's one of the library provided by the AWS Lab, so that it can use the existing router, the router which has been created, and it can mostly port or wrap as per the AWS Lambda. So we are doing the same thing at the global level. We are just initializing this just GIN Lambda. We are doing the initialization of part this thing. So one of the, we can say, a small drawback of AWS Lambda is because it's going to run a function periodically. So function initialization time is going to take some time. So that is called as a cold start time. We can reduce the overall call starter for the successive calls, and that's why, so the calls which require to do one-time initialization, it's recommended to put into the initialization block, so that for the next successive call, this block will not reinitialize. So we are just doing the same thing here in the initialization bar. We are just initializing the router. We are also saying that if someone is going to hit for this /endpoint, just return hello serverless. And then we are initializing our GIN Lambda, which is a proxy, and we are passing the router. So this handler will be starting point for the AWS Lambda. It accepts few things. One is context, which has a lot of information. It has information about the X-ray. If you are enabling the X-ray, it has information about from where the call has been initiated. A lot of information in the context. And then it just provide another thing, which is a proxy, API request proxy. Then this proxy will have information about the exit path that it is calling. Then we are just in wrapping inside the GIN Lambda proxy with context, where we are passing both the things. And then the starting point will be lambda.start. So it's like a same, like it will wait for the request, then it will call the lambda.start, it will call the lambda. We already have a router which is already initialized. We are good to go. And when someone is going to hit this URL, is going to call hello serverless. So we have seen that lot of code, for example, for the router as well as for when you are writing a basic Golang application, most of the code is same. Only a small wrapper is required when we are running this code for the AWS Lambda. So let me quickly open my editor and just walk you through on how we can make sure that we are trying to use the same code. And I will also walk you through what are the practices which AWS recommend when we are going for the AWS Lambda. Now I'm going to show you that how we can use the code sharing. That means the code which has been written for serving the AWS Lambda, we can also run the same code locally. One of the main challenge of running any of the serverless technology code locally is how can test everything locally. So there are a lot of tools available. One of the great tool for especially for AWS is called as local stack. By using that local stack, you can also run AWS Lambda locally. Internally, it just deploy into this local stack environment, which is equivalent to AWS Lambda environment. And by that mechanism, we can test it out. But again, deploying that code, it's a time consuming process. So this is a simplified process which I am figured out. And I hope that you are also going to get some benefit of that thing. So the solution is pretty simple. We need to identify what is the common code. This is also one of the recommendation from AWS Lambda is to keep your initialization code separate from your business logic code. So in our case, consider that our business logic is to serve our HTTP request. In that case, we are just moving that code, especially for the routing code, into a separate file. Let's call it router.go. And then on our local.go, which is going to run on the local system, we're just mentioning here that just call the router and just initialize the router. It was the same code which I have shown a few seconds back in the presentation, that we can run a basic Lambda code, just initialize the GIN router and run the code. So this is good. We can quickly test it out whether this is working or not. I'm going to run the same code, go run local.code, which is pointing this local folder, and it has started listening on the port number 8080. I'm just using one of the feature of, I'm using this Golang tool for all this kind of a development purpose. And this is one of the good tool, especially for the Go language. You can also use the same tool for the VS Code, the same principle which I'm showing here, it will be work. And I also request the organizer to share the GitHub link along with the presentation. So now the port is running on 8080. You can see I can directly call a request, which is our get HTTP request, and we can get the data, which is hello world, which is coming from this router. The router has been initialized, and here we can get the hello world thing. Similarly, if I want to write the code for Lambda, and I need to kind of follow the same principle that the initialization code will be separate and the business logic code will be different, then this is how it's going to be happen over here. Again, the main is kind of a starting point for us. Then we are initializing everything. We are taking the router information. Okay, in our git initialize, sorry, in our Golang initialize, we are just initializing the router. Then we are also using AWS Lambda proxy. Inside the proxy, we actually created a global variable. Here we are just passing, we're just creating the kind of a global object, new adapter, and passing the router. And then this is the starting point of AWS Lambda, especially for the HTTP request. We got the context, we got the request, and this will be the response. And we are just, since we are using this AWS Labs Gen proxy, it just kind of wrap everything, and the same code will work for both the things. Now, this is how we are able to kind of share the code between our local thing and Lambda, and we can kind of run this entire code too. There are various options for the deployment, but for this presentation, I'm going to use serverless application model, AWS SAM, for the deployment. So the other options could be, we can deploy using a Terraform, we can deploy using CloudFormation, we can deploy using Plumi, or we can deploy using AWS CDK. But if you're going to do for some sort of POC, then this SAM will be kind of a much easier for the deployment. We need to install a SAM CLI, which is equivalent to our AWS CLI. After installing same CLI, we need to run a command which is same initialize. So this is going to ask you a couple of things. It has a couple of boilerplate project for the Golang, for Rust language, for Node.js, multiple languages, and we can also choose a custom project also. So I already installed this SAM initialize, and it has created kind of some project. So after running a SAM initialization part, it has created some sample project for me. I actually taken the respective information which is required to run this application. Those include a Makefile where we are going to run a SAM build command, a template.yaml file which is responsible for kind of it is mostly equivalent to a CloudFormation template, but it's mostly configured based on SAM way so that we can deploy our Lambda, and a couple of modification has been made so far. So, and this is kind of one of the important thing for us, is because this is will tell us what kind of thing we need to do. So it start with a folder location. So when I'm going to run my build command, which is my back build command, is going to generate the artifact, but this build command will utilize this same template. It's going to see where the code path is. In our case, the lambda server.go, that was where the code was there. It will create the name of the handler. So this handler will be it's kind of a logical name for the handler. Then which runtime we need to use. So the Lambda support multiple runtime, Node.js, Python. So similarly, right now it's supporting Go.1.x version. Then you can select an architecture. So AWS Lambda support two kind of architecture. One is we get called as x86-64, and another one is ARM. For this, I'm just selecting an ARM. Then it will ask for when we are going to invoke this Lambda, when this Lambda is going to be called. So here we are saying that this event will have a logical name. Catch-all is just kind of a logical name. And then the type of event will be an API, which is kind of a API request from your API gateway. And it's going to create the API gateway for us. And when someone is going to say a specific endpoint get request, then this is going to invoke. At the output of this one, when I'm going to run sam build command and send deploy command, is going to generate the entire structure stack for me. And once the structure is ready, then we are going to see a couple of URLs at the end. So what I'm saying to this SAM framework is, or I would say internally, it's actually calling a CloudFormation template. So what I'm saying to them is just create an API gateway for me, and just also share the API gateway URL at the end of it. After deploying the SAM template, it's going to generate an URL. The format of URL will be something like this. This will be kind of a name of API gateway. Execute API is going to make an execute call to this API. We have this prod, which will be the default stage environment. And when I'm going to hit this URL, again, it's a GET request call. So it's going to make a call to that Lambda and is going to print hello world. So this hello world is same like which we have seen on a local system. When the code was running on locally, this is the same thing over here. And this information is coming from the router. So we have seen that we can do kind of code sharing part of that thing. We can kind of write the same code which can be used by the Lambda and local. Now this is mostly all about the AWS Lambda. Now let's come back to the next section, which is our GraphQL. So GQLGen. So I'm going to most talk about the GraphQL part. So GraphQL is a query language for API, and that was developed in 2012 by Facebook, and they made open source as 2015. It was mostly designed to improve the efficiency and flexibility of API by requesting to fetch the data which is only required and to retrieve multiple set of data in a single request. And GraphQL is a strong type schema that offers structure of data and that can query, and query language that allows client to specify the data they want to retrieve. It can be used in any programming language and backend technology. So when you are talking about the GraphQL, we only need to think about the schema. So this schema will define everything. It defines what kind of model we want, how we want to fetch that model, and how we want to update that model. So schema is kind of a core for GraphQL. And after that, there are two important concepts, which is called as query and mutation. In case of traditional REST application, we have multiple things to update the data. So for example, we have put request, post request, delete request. So these are all the operations which is used to kind of update the data. In case of GraphQL, that is called as mutation. So whenever you want to perform any sort of update, which also include the deletion of that object, it's called as mutation. And when we want to fetch the data, that is called as query. So query is nothing but just get the data, and mutation is just kind of modify the data. Let me show you a quick example of GraphQL schema. So we have query for fetch the data, we have mutation for update the data, and we have different models. So now let's consider a simple example that we want to create a to-do app. The to-do app will require an ID, title, description, and complete it. To get the data from the API, we are going to have another input when we are saying that, okay, if you want to create a to-do, then we need to pass a title and description. Here the description is optional. If you see an exclamatory mark, that is this is required property. Similarly, when we want to update any of the to-do, we need to pass the title, description, and the status whether it's completed or not. Okay. In case when you want to query, here we'll say that, okay, we are going to get the to-dos, and to-dos will going to get the list. So if you can see, this is array option. We have a square bracket inside. We are passing a model. The model is required, and this return is also required. Even if it's going to return the empty object, that is perfectly fine. Similarly, mutation, what are the options we can perform? We can perform create to-do, update to-do, and delete to-do. Now this is all about the GraphQL schema. Now what happened is, now someone is going to say, okay, if I want to get the data, if I want to update the data, in our typical RESTful application, we used to create a controller, we used to create a routing and everything. In case of GraphQL, instead of creating a controller router, we need to kind of mention the resolver. For example, now this is kind of a simple example. Let's say if I want to get the to-do, which has ID, title, completed. So this information will be linked to a particular set of function which is going to execute. Now it may be possible that the ID, title, and completed, these are going to come from different functions. So we can have a nested resolver also. In our GraphQL GQL generation, we'll see that how these things are getting linked. So please bear with me for another 5 minutes. Now, what is GQLGen? So GQLGen is a Go library for building a GraphQL API. It generates TypeScript server code based on the GraphQL schema and resolver functions that you define. So we talk about the schema. So resolver is nothing but the function which is getting executed and is going to either update the data or is going to get the data. So with GQL, you can define your GraphQL schema in a GraphQL schema language, and GraphQL generates Go code for your server that handles the queries and mutations. This eliminates the need for manually parsing incoming requests and serializing outgoing responses. The GQL is built with the performance in mind and uses generation to code efficient and type-safe code. To getting started with the GQLGen, we need to run a simple command. This command is nothing good to initialize the GQLGen. We need to kind of run the command go run github.com 99 designs and GQLGen initialize. It's going to initialize the setup. It's going to create a dummy project for you. And once the setup is done, we also need to resolve the dependency. I already did this thing. So let me quickly walk you through on the code part, it has been generated. And then we'll go in more details about how we are going to integrate with AWS Lambda. After running GQL initialize command is going to create a folder structure which is equivalent to this one. The starting point for the GQL is to understand the GQLGen YAML file. And this YAML file has a lot of information. So let's go by a bit of information from here. So it checks with the schema where the schema is available. So here is mentioned that the schema is available on a GraphQL folder. So it go to the GraphQL folder. It will check for this file extension GraphQLs, and here it's going to find out the schema. And based on this schema, it's going to create the resolver and the model. And then it's going to check what will be the file path. If you want to change the file path, we can change the file path. Here it has uses this GraphQL generated.go. So this is the generated.go is a kind of auto generated file after the initialization. Similarly, it's going to create a models for us. The model will be, if you can go back to our schema, we'll see that we have this to do. This is one model, and new to do. This is another model. So it's going to create models new to do and to do based on the file which you are going to provide. So here it's mentioned that the models underscore gen.go is the place where it's going to create a model. Now, if you already have an existing model and you don't want to create those models by this code gen, by GQLGen, so what you can do is you can have one more option which is called as auto bind, and here you can mention the path of your model. For example, in one of the example, I'm going to show you that I already have a path where I mention my model, and then I'm just telling the GQLGen that use the existing model, don't create the new model in models underscore gen file. Now, so this queries and mutations, it has different kind of functionality. For example, we require one resolver. Resolver is nothing but the function when someone is going to request for this query, and then we require another create to do. I just want to kind of create as simple as possible, so I just put the create to do where I'm going to put the to do information and it's going to create this thing. So the base class for the resolver is resolver.go. It has nothing. It has just a simple thing. This can be used as a dependency injections. I'm going to cover that part as well. And then it's going to create a schema. Now, so if you want to have a separate schema based on the file name, that is also possible. That is something that we can configure here, that what kind of schema we want. And it's mentioned that, okay, just follow the schema. Based on the schema, just create the resolver. So we have this schema resolver, and it has multiple function, which is actually not implemented. For example, we are looking for to-dos to get the kind of query information. And it's mentioned here that this to-dos does not implemented. This is where we need to put our code. Similarly, it has created a resolver for create to-do, which is mentioned here. So we require one more resolver for the create to-do, and it has created a resolver that is also not implemented. So we need to put the logic over here to create it. Now, thing is, I just want to show you the entire end-to-end flow where I can perform a basic code operation for that thing. And I'm very fond of AWS. So what I've done so far is I created one AWS sample where it's going to kind of get the data from the DynamoDB and update the data from the DynamoDB. But before going to more on how this is going to be implemented, I just created a very simple sample where we can see that how we can perform basic CRUD operation on DynamoDB. So the main thing is with the DynamoDB is its code is a bit complex to understand, but there are a lot of libraries which are kind of a wrapper on the DynamoDB to make our life easy, and one of them is Dynamo. Now what this Dynamo does is we need to mention the schema. So it's like we have an object where we need to just do a CRUD operation, basic create, read, update, delete operation, and we need to say okay, now this ID is linked to particular this ID into the table, DynamoDB table. Similarly, user ID will link to user ID table, and likewise we have other properties which can link to specific attribute to the DynamoDB table. So consider this, because DynamoDB is like a key value pair database, so we can't use a term column, but right now we can use a term kind of column where we have this ID, user ID, text, and done. These are kind of attributes, or we can say properties of a particular document in DynamoDB. And then we're just initializing a new AWS session. So this new session is in case when we want to kind of do anything related to the AWS, we need to initialize this AWS session. Here we can also provide the which region we want. We can also provide the credentials as well. I'm going to pass the credentials and region using an environment variable, which I'm going to show you in a few minutes. And then I'm just initializing my Dynamo, which is kind of a wrapper on the DynamoDB Golang library provided by AWS. And then I'm just selecting a database table. For me, I just already created a table to save all of our time. And then I'm just creating an object for the table. It's like a struct for the table. Running a put command is going to add this information, and then here I change a schema a bit. I'm passing a user ID with this thing, and at the end I'm just making a call to again the DynamoDB table. Here I'm saying okay, give me the information based on the user ID, and it's just returning me this result, and this result will be visible. A very simple example. So the main purpose of showing this example is that we are, for our actual application, we are going to use DynamoDB, where we are going to see the things end to end. Okay, now the GQL code which has been generated so far, I have modified that code. So this is kind of updated code so far. It's a bit clean code compared to what it has been generated. So let me quickly walk you through on that code first. Here I just mentioned AWS, where client, I'm just providing a session information. Okay, this is the session information for us. We have this GraphQL, which is same auto-generated. Now we have a model, to-do model, which I shown you before. We have this ID, user ID, text, DynamoDB. These are the attributes on that part. Now I'm just mentioning this GQL generate that do not create a new model for us. Don't create a new model for me. So it's not created over here, and this is possible by providing a path where it can use a auto binding. So my to-do models, this model folder is a part of this auto binding. So GQGen will say okay, this model already exists, so I don't need to create another one, and then that's why it's just ignore that model. Then I created a service because the code which was in Dynamo, it's just for the POC, not for the actual code. So I just created a to-do service. And this to-do service is actually doing two things here. It's just adding a to-do. In that case, it's just generating a unique ID. It's making a DynamoDB table call. It's making a put request, getting the data, and then we are good to go. The new table will be added when someone is going to call to this service. And similarly, we need to fetch all the users' informations. We need to fetch all the 2D information by the user. So here I'm passing a user ID. There it is again scanning the call. It's passing the user ID, and then we are getting the result, which is kind of model for us. So this is a simple service that we have. Now Now coming back to the server.go code, so this code has been kind of modified a bit so that we should use the Gin framework. So far, the auto-generated code from GQLGen does not have this concept called as Gin. They have a documentation that how we can integrate with the Gin, and I follow the same documentation, and this is the code we have. Okay, so again the code start from very simple thing. Main, here we are mentioning the port number. If the port number is not mentioned, we are going the default port number. We are initializing the Gin router. We are actually initializing two more endpoint. One is query, where we are going to perform the GraphQL operation in the playground. So this GQLGen support a playground. We can use the same playground again, or we can use something else. I'm going to show you one more Chrome extension that you can use, and you can play around with the playground. So this GraphQL handler, here I'm just initializing the new Dynamo client, initializing the new to-do service, and I'm passing this information to default handler server. So this handler server is actually provided by our GQGen. It's provided by GQGen, and I'm just initializing this handler server, and then when the server is initialized, I'm passing this information to the Gin context. For the resolver which has been generated here, I'm passing the to-do service as a dependency over here so that the resolver have all the information about the to-do service. So this is the basic configuration that we have done so far. And now the GQLGen has know about to-do service, and it has the instance of for the to-do service. Now if I'm going back to my schema again, now I need to fetch the data for the to-dos, and I need to create a new to-do. For that, the GQLGen has already created a resolver for us, and here we are fulfilling that information. So for the create to-do, which is for the mutation operation, we are just adding into to-do, which include the text, user ID, and done, current status, which is false. And for fetching all the to-dos, we are just passing the user ID, and it will return us information over all the user IDs. It will return the information about all the to-dos based on the user ID. To quickly see this in action, I'm going to run here. So let me stop my existing server. Let me go to specific this folder, and here, like I said, that I'm going to run this information on AWS cloud, and I'm going to use my existing profile. So you can pass your AWS credential here, or you can also configure AWS profile for the same. I'm just configuring the AWS profile, and the thanks to Take9, so they are allowing me to use their AWS cloud for this purpose. And I'm mentioning the region information. So this two information is required for DynamoDB, and where's east? Okay. And then I can run the same command. Go run server.go. Now what can I do here is I can quickly show you that the entire thing now it has started the server. Now we can see that it has two endpoints. One is a GET request endpoints, which is pointing to a playground, and we have post call, which is actually calling to this, which is actually handling this resolver schema and everything. So when we open this port number 8080, where the GQLGen server is running, it is going to show us the playground. So this is kind of playground. So we can see there are multiple programs provided. This is default playground provided by the GQLGen, and we can also see the information about the schema. So if you can see the documents, it has query and mutation. The query has this to do where we need to pass the user ID, and mutation where we can kind of create a new to do. So I'm quickly going to show you a simple example. We have query to do's. If you can see the to do, it's asking for user ID and then text and user ID. So this is the information when we are saying that okay, this is the information we are passing you, and at the return just return me text and user ID. If I'm going to run this thing, we can see we are getting text and user ID. If I'm going to bypass any of the field, let's say I only need a text because I already know the user ID, this information is going to become. Now we can see that the information which is coming from backend is not kind of a is this something that we are asking for. So this is one of the kind of a major advantage of GraphQL. Now, apart from query, we can also run mutation where we can create a new data. So here we are saying that, okay, create a to do, just pass some random values over here, the text, and for the user ID. So if I'm going to say for the user ID to create it, and then return me only the ID. If I'm going to run the same command here and say that I need to have for the second user get the data, and I'm going to run this thing again, so you can see that it's just returning me for the user 2, and this is for the user 1. So this is all about the playground in this thing. Now let's see how we can deploy the same thing on AWS Lambda. Now for the Lambda, what I have done so far is I just created a common code which is mostly a router code into the router.go file. We can quickly see we have this router, we have the information about the GraphQL handler, playground information. It just initialize the router and it just kind of return the path of the router. And then I created two different folders, one for for the local, which is for the local operation, the offline mode, and then lambda main.go, which is to run the application on Lambda. The main local main.go is nothing but a simple initializing router, passing the port number to the router, and then Lambda has the same configuration, initializing a router, which you have seen as a code sharing slide, and then we are just creating a proxy and we are just starting the Lambda. So that's it, we are doing it. For the deployment is almost same, nothing has been changed. Only one thing which has been changed so far in the deployment is because this application require a DynamoDB access, so we actually added a DynamoDB access over here. We are just passing a customized role information. We are saying it can perform get, port, query, scan, update operation on the DynamoDB database, and then the function that we have, I think everything is same. The path is Lambda folder. We have kind of customized name for the handler name. It is using this runtime go.x 1.x version, and it is using a specific role, and that role has been created over there, which has the DynamoDB access. The rest of the things are same. Now, one more, there is a very small difference over there. If you can see the queries, it has only two things. So we have this get query for the playground, and for the post query to do kind of a query or mutation. So in GraphQL, everything is mostly a post operation. So if you want to update something, we need to use the HTTP verb, which is post, or if you want to use any get the data, we again going for the post operation. So this is the entire configuration that we have. Here we are mentioning that we need to kind of open two endpoint. One will be a get and another will be a post. Post is for query and get is for the playground, and that's it. And then again we need to run the same command, same build for building this structure, and same deploy. And during the same deploy, it is going to ask you a lot of things like what will be a CloudFormation stack name, other information, your bucket name, and once the deployment is done, you are going to get an URL. So, and this time I'm going to show you a different Chrome extension, which is for the playground, and we'll see how we can play around with the same thing. And the code is deployed on AWS Lambda. So this is kind of a different variation of playground. So we have seen this playground, which is provided by the GQLGen, and this is kind of a Chrome extension for us, which is kind of very standard playground for GraphQL operation. We can see schema here. We can see the schema over here, and then we can perform the same operation. We can do again the query call with get, and the user information is going to return the data. We can quickly check for different user is returning this data. I can check for the specific thing, and the important thing is the URL which you are seeing over here. This is actually pointing to an API gateway, And this is the endpoint where we are heading so far. Similarly, we can also do the mutation here. I can put some more content here, update, and then again run the same query for the same user. And now you can see my contain this value which has been put, it's available. So this is all about how we can use the GQN generator for creating the resolvers and how we can kind of deploy this thing on AWS Lambda. Thank you so much for watching these presentations. I hope that you have learned a lot of things from these presentations. And before I sign off, I just want to give some information about my current company. I'm working in Take9, and this is the fastest growing company in the world. We have offices in US, India, and Latin America. And you can reach out us on LinkedIn, as well as you can call us on the mentioned mobile number. So thank you so much.